Hello guys, welcome back to Maison African Motives, still on engineering science N3. In this platform, we are going to be working from the question paper, which was extracted April 2015, that is motion, power, and energy. So we have the first question on 1.1, where we are given to define the term machine. Okay, what can we refer to as a machine? All right. So take note that a machine is simply a mechanical device which can enable work to take place. That is what we can refer to as a machine. So you can write this as, all right. So let me just try to reduce this one. Okay. So you can have a machine as a mechanical device. So this is a mechanical device, right? That's a mechanical device, right? Which enables work to take place, all right? Which enables work to take place, all right? So we can even add that more effectively, or it can be more easily, okay? So a mechanical device which enables work to take place more easily, all right? So that's what we can easily give as a definition for a machine, okay? So that was 1.1. On 1.2, we are given that a ball with a mass of 2 kgs rests on a plane, on an incline, sorry, with an angle of 10 degrees, okay? The ball is to be released to roll down the inclined plane, neglecting all friction. So take note here, we are told to neglect all friction. All right. So on 1.21, we are given to determine the following: the loss in potential energy after it has rolled 12 meters. All right. So this is what we actually have in this case. We are given that this is a ball which is on the top here. So we are given a ball that is on the top. So this is 1.2, and it is to roll down the inclined plane, which is settled at an angle of 10 degrees. Take note, this is at an angle of 10 degrees in this case. All right. So this is where we are having our ball in this case, which is going to roll down the incline. All right. And we are given that this is going to take, all right, let's see, as the ball has got 2 kgs, all right, so the ball here has got 2 kgs. We're given the mass of the ball, which is 2 kgs. So here with a mass of 2 kgs. All right. So as the ball is going down, take note, it is going to cover a certain distance. That's from this point to where the ball is. It is going to cover a certain distance. And also, there is going to be the perpendicular height, which is going to affect, as the ball is on top, it is affected by the perpendicular height, which is h, all right? So we shall see this later on. So the question here is to calculate or to determine the loss in the potential energy as it goes down. So it's going to be a loss in potential energy. All right. After it has rolled 12 meters, take note, we are given the distance the ball is going to roll from the top to the bottom, which is 12 meters. Take note, we are told to neglect the frictional force, any friction, okay? So in order for us to obtain the potential energy, we know that potential energy is equal to mass times the gravitational acceleration times the height. But in this case, the height is being affected because of the 12 meters. It's going to affect the height and the angle of 10 degrees. So according to this angle of 10 degrees, the height that we have here is opposite, okay? So this is opposite, and this is the hypotenuse to this, okay? So we know that from our SOHCAHTOA, we are going to apply the sign, okay, please, from your trigonometry, that's SOHCAHTOA in this case. So where do we have opposite and the hypotenuse is for sine? So that means the sine of theta is equivalent to the opposite over the hypotenuse. So take note, we want to calculate h. So in this case, we are going to have the opposite and the hypotenuse, that is sine of 10 degrees is equivalent to the opposite, which is h, over the hypotenuse, that is the distance of 12 meters. So we can write our h, which we need in the formula, by cross multiplying. 1 times h is equal to h. 12 times sine of 10 is going to give us 12 sine 10 degrees. Okay, so this is the indication or the presentation of our height in terms of sine 10 degrees. Okay, so we can substitute this since we are given all the values that we need. That's the mass is given of the ball in kgs, which is a mass of 2 kgs, times g, the gravitational acceleration of 9.8 meters per square second, times the height, which is 12 sine of 10 degrees. So this is going to be 12 sine 10 degrees. Okay, so that is the indication that you're going to have. So guys, I want you to use your calculators properly. In this case, we shall have our potential energy as 40 comma, so this is going to be 40 comma 842 if we round off properly. In this case, okay, so that's if we round off properly to 3 decimal place, we shall have this as 40 comma 842, that is in joules like this. Okay, so we have our potential energy, which is 1.21. Okay, let's check the other part of the question. That's 1.22. All right, so on 1.22, we are now given to calculate the kinetic energy after it has rolled 12 meters. Okay, remember guys, we were given the potential energy, that the one that we calculated. So after it had rolled 12 meters, that's the same as the potential energy that we have at the top, okay? Because we are calculating using this height, okay? So we are referring to the potential energy that we have at the top. That is going to be equivalent to the kinetic energy. So on 1.22, our potential energy, which is the kinetic energy, sorry, at the bottom after it is rolled, is going to be equivalent to the potential energy at the top. So which is just direct as this potential energy, which is 40.842 joules. Okay, so that was your kinetic energy in this case. Okay, so after that, we are now asked to calculate the velocity after it has rolled 12 meters. Take note, we are still working with 12 meters. And we have the kinetic energy after it has rolled for 12 meters. So we can take advantage of the kinetic energy because we know that in kinetic energy, we have got velocity in this formula. So from 1.23, we can take this from our kinetic energy because we know that kinetic energy is half mv squared. All right. So if kinetic energy is equivalent to half mv squared, that means we can make v the subject, or we can just substitute the values, then we calculate, or just make v the subject. So in this case, this is same as over 1. So you can cross multiply from your mathematics. That's 2 times this. This is 1 times this. So it's 1 times 1 v squared, which is mv squared, is equal to 2 times e, which is 2ek, like that. Okay. So remember, we want to remain with the formula for v. So we can divide by m both sides so that our v squared is going to be 2ek over m. So to find v, remember, it's a square. So we introduce the square root both sides. So that means the formula for v is going to be the square root of 2 times the kinetic energy over the mass. All right, which is, we can simply substitute because we have these values here. So we are going to have it as the square root of 2 times the kinetic energy, which we said is equivalent to the potential energy of 40.842. All right, so that's going to be 40,842. All right, so we've got 842 over the mass of the ball. Take note, the mass of the ball is given here, which is 2 kgs. So we are going to divide everything by 2 kgs. All right, so this is going to be the resultant. Everything over, take note, everything is under the square root. So that is going to be our velocity. So if we simplify properly, this is going to be 6,391, which is velocity measured in meters per second, or you can write as meters per second like this. Okay, so it's still one and the same presentation. Okay, so that was question 1.23. On 1.24, we are now asked to calculate the original height. Take note, guys, this is what we have. The original height of the ball that the ball is rolled from, okay, in order to reach the bottom of the slope at 20 meters per second. So we are now having a certain velocity. So the question is, what is the original height? All right, this is what we know, guys. From the velocity that we are given the velocity of 20 meters per second now. Okay, so this is what we can do, all right? We know that the height can be determined from the potential energy, okay? We do not have the potential energy, but we are given the velocity of 20 meters per second. So remember that the kinetic, if we can calculate from velocity, we can have the kinetic energy, which is equivalent to the potential energy, just like what we did previously. We saw that kinetic energy at the end up was given the potential energy from the ball that we had at the top to the bottom. So it's the same scenario that we are having here. We can calculate the kinetic energy because we are given velocity. And from this kinetic energy, which is equivalent to the potential energy, we can calculate the height because remember that potential energy is equivalent to mgh. So this enables us now to calculate the height because this is going to be the unknown. All right, so let's take advantage of the velocity to calculate kinetic energy, which is equivalent to potential energy. Remember, kinetic energy is half of mv squared, which is half times the mass of the ball. It does not change. We still have our mass here, which is 2 kgs. So that's 2 times v squared, which is 20 squared. All right. So if we are to calculate this, we are going to obtain 400 joules, which is our kinetic energy. But we say this is equivalent to the potential energy. So we have got 400 joules in this case. So in order for you to have the height, by making h to be the subject here, by dividing by mg both sides, this can give us the height. Thus, the height is equivalent to the potential energy over mg, whereby the potential energy is the same as the kinetic energy of 400 times everything over the mass, which is still the same here of 2 kgs. So that's 2 times the gravitational acceleration of 9.8. Okay, so from this, we can have the original height from the information that we have, which is 20,408. If we use your calculator and round off properly there. All right, so as you can see, guys, these are the typical questions, and you have to be very, very careful how to interpret the question and the information that you're given. How can you use the information from one question to answer another question like that? So that's how we simply have these questions. Okay, anyways, let's check what we have on the other part on 1.3. Okay, so 1.2 we are done. We move on to 1.3. So on 1.3 we are given that there is a train with a mass of 120 megagrams. Okay, so this is megagrams. Okay, accelerates uniformly on a horizontal. So this is supposed to be horizontal here, horizontal track. The resistance to the movement, okay, the resistance to movement is 5 Newton per kilonewton of the mass of the train. Take note, it's 5 Newton per kilonewton of the mass of the train. So that is per force of the train, okay? The force in the drawbar of the locomotive is 80 kilonewton, okay? So this is what we have, guys. We've got the train and the part of the force of the drawbar of the locomotive, which is 80 kilonewton, okay? So I'm just going to list this information down. Let's see if we can have a space enough here. Okay, I think this is enough. Okay, let's see from this space. Let us try to list down our information. So the first thing is we are given the mass of the train. Okay, so this is our train, which has got a mass of 120 megagrams. Okay, so take note, mega is times 10 to the exponent of 6. All right, so this can enable us to convert this mass. Our mass is supposed to be in kgs, okay? So if we multiply this by 10 to the exponent of 6, we are going to obtain 120 million grams like this, okay? Which, if we convert to kgs, that's divided by 1,000, because we know that in a kg, we have got 1,000 grams, okay? So if we have got 1,000 grams, to convert this gram, we are simply going to divide by 1,000. That's these zeros will cancel. So we are going to have 120,000 kgs. Okay, so this is the mass of the train. Then we are given that the resistance to the movement. So the resistance now is the force, that is the resistive force, which is, we can write as Fr. So we are given that it's 5 Newton per kilonewton of the mass of the train. Take note of the mass of the train. Okay, this is mass. So we are going to affect now to say, in terms of the force that we are given in this case, we are given that the train has got a mass of 120,000. So what is the force? Because kilonewton means force. So we need the force of the train. According to the train, we need the force affecting the train, which is going to be mass times the acceleration, in this case, which is the gravitational acceleration. So the mass of the train in this case is 120. So we're going to have 120,000 kgs times 9,8, okay, which is going to be something like 1. So it's going to be 117,600 like this Newton. Okay, but we are given that it must be per kilonewton. So you have to convert this to kilonewton. Remember, I told you to convert to kilonewton, kilo means times 10 to the exponent of 3. So to convert to kilo, you multiply by the inverse, which means you multiply by 10 to the exponent of -3. So this is going to be 117. So we're going to have 1176 kilonewton. So this is the force that is affecting the train. So we are given that the resistance now is 5 Newton per each kilonewton. So each kilonewton, there is 5 Newton. So we have got 1,176 kilonewton. So what is going to be the total resistive force? So we can calculate the total resistive force in this case as 5 times the number of kilonewtons that we have, which is 1,176. Okay, so this is going to be something like 5,880 Newton. Okay, so that is the resistive force. Okay, so we are still listing the information. So I think from the information that we are given, it's enough. Let's check if we are given anything. Then we are given that the force in the drawbar of the locomotive is 80 kilonewtons. So we are given this is the force of the drawbar. So for the drawbar, in this case, we are given a force of 80 kilonewton. All right. So the question is on 1.31. calculate the following: the force required for a constant speed. What is the force required for a constant speed, which is the total force? So this is the force which affects the accelerating force, but if we are given a constant, guys, take note here. If the speed is constant, it means there is no increase there is no increase in terms of the object is not accelerating. So the acceleration at that moment is 0 meters per square second. So that means the resultant force now is going to be like this. Okay, this is 1.31. So the resulting force, we remember it was supposed to be the accelerating force plus the resistive force. All right. But the accelerating force, which is supposed to be mass times acceleration, is not going to work because we are given that it's constant speed where acceleration is equal to 0. So that means whatever that you are going to multiply the mass and its acceleration, which is a 0 here, we are going to obtain a 0. Okay. Plus now the resistive force, which is the one that we calculated from that information. Remember, I calculated this from this information and we got 5,800. So it's going to be 5,880. Okay, so that is going to be the same because if we add a 0 here, it does not affect. So it's going to be 5,880 Newton, or you can convert to kilonewton depending with the question that you're given. Okay, so that was question 1.31. On 1.32, the force that causes acceleration. So we must calculate the FA, which is the accelerating force. Okay, so in this case, this is what we have, guys. Remember, we are given a drawbar. This having a force of 80 kilonewtons. Okay, so if we are to use this, this is the total force that we are actually having. When it is constant, when we have got a constant speed, the force that we have, it's 5,880. So this is going to be the force that is resisting the 80 kilonewton because now there is a movement in the drawbar. So that's where we are having this force. So it means if our force previously was given as FA plus FR like this, we are now going to find our FA in this case by just making FA the subject. We can substitute, we can transpose FR to the other side. So that means our formula is going to be F minus FR, which is equal to FA. That is our accelerating force is equal to F, the force minus the resistive force. So like I was explaining that the force in the drawbar now is the maximum force that we, so that's your total force in this case. So this is the one that you are going to use, but take note, this is 80 kilonewton. Kilo means 1,000. So that's 80,000, okay? So we shall have 80,000 minus the resistive force, which was that force at constant speed when there was no movement in terms, when there was no change in acceleration. There was a constant speed, which means the acceleration was, that is now your resistive force, which is 5,880. So take note, be very, very careful. This is how tricky the question was going to be. So this is going to represent your FR this time. Okay, so subtracting these two, we shall have 74,120 Newton if we subtract properly. So that's our FA, which is the accelerating force. All right, then the last part now is to find or to determine the acceleration. Remember, this FA is equivalent to mass times acceleration. So it can be easier now to calculate the acceleration because we know that, okay, this is what we know here. That's 1.33. We know that the accelerating force is equivalent to mass times acceleration. So to calculate the acceleration, we simply divide by the mass, both sides. So that means acceleration is equal to the accelerating force over the corresponding mass. That is the accelerating force, the one that we calculated here of 74,120 Newton over the mass. So the mass, which mass are we using? That is the mass of the train. Take note, we are referring to the train, and before we calculated the mass in kgs, we obtained 120,000. All right, sorry for that. So this is going to be, okay, let me take it back. All right, sorry for that, guys. So this was over like this. So we have got 120,000 like this. All right, so if we are to divide this, we are going to have our acceleration as 0,618 meters per square second. All right, so this is meters per square second. So that is going to be the resultant acceleration. So therefore, our acceleration is equal to 0,618 meters per square second, or you can write this as 0,618 meters per square second like this. It's one and the same way presentation. Okay, so that was 1.3, which was actually 2 marks, okay? 2 marks for everything. So as you can see, guys, these are typical questions. They will ask these typical questions. They want you to convey, they want you to understand how to convert the issue of conversion of units, all right? And also the application of formulas. This part they will skew. So please, you have to revise as much questions as possible. Work with question papers, revisions, your textbooks, the videos that we have at Mason African Motives, and so on. So many things that you can use to revise. What is important is for us to revise as many questions as possible. Okay, so that's what we had, guys, for Mason African Motives. Till we meet again.